Hello class, I'm Mike Ferguson,
And I'm Ji Peng Ma.
and today we'll be explaining a common industrial issue known as a water hammer. Water hammer is a phenomenon that occurs in piping when a flow is suddenly impeded through the closure of a valve. So say we had a tank with a flow of UI. If we suddenly close the valve at the end of the tank, a region directly to the left of the valve will have a velocity of 0. At this time, the upstream liquid will be flowing at a speed of UI. Because the liquid is only able to compress a small amount, the liquid in the velocity equals 0 region is a distance governed by the speed of sound. Using Newton's second law, we could find the pressure at the interface of the moving and stationary liquid. The pressure at point 1 should equalize the momentum of the liquid in minus the momentum of the liquid out of the control surface. Since no liquid flows out, that term is 0. Since the area terms cancel out, the pressure equals the density of the fluid times the speed of sound times the velocity of the fluid at point 1. This is also known as the Joukowsky equation. This pressure shock wave will continue to move up the pipe until it reaches the tank, at which time a negative pressure sends the shock wave back up the pipe. This fluctuation will continue until friction losses dissipate all of the energy in the system. If we look at a control valve with a pipe on either side, we can see that the shock wave will still exist upstream and propagate in that direction. The buildup of pressure in the pipe can cause pipe walls to fail and explode if the walls are not designed to withstand the stress. Downstream of the control valve, liquid continues moving at the initial velocity. This causes a vacuum to form directly downstream of the control valve. If the pipe wall is strong enough, this will cause liquid to evaporate and fill the space. This vapor will cavitate when liquid is reintroduced and can cause shock waves that chip away at the pipe. However, if the pipe wall is not strong enough, the negative pressure will cause the pipe wall to collapse radially. In order to mitigate the effects of a water hammer, an arrestor can be placed upstream of the control valve. The arrestor is a piston full of air that will compress in the event of a water hammer, allowing water to rush into it to relieve pressure from the shock wave. Downstream, air relief valves can be implemented, which open the pipe to air in the event of a vacuum. This will equalize pressure inside and outside of the pipe to protect the pipe from damage.